Good morning. Good morning, everyone. Good morning to each and everyone. I'm fine. I hope you all are fine. Good morning, Janvi, Aditya, Bhumika, Akshra, Sneh, Ria, Sneh, Aditya Jain, Navya, Jastaran, and all others present here. Raghav, Vanchika, Mahi, Vanchi. Good morning, Dennis. Just in a minute, we are going to start with the question. We are starting with the exercise 8.2. As yesterday we have done the new theorem, midpoint theorem, and the converse of the same theorem. The theorems are very important, and even from the examination point of view. So do that. Practice that. Aditya is asking for the solution of this midpoint converse theorem. You can see, Aditya. Is it done? Aditya, have you seen this? Is it done? Okay. Okay then. So exercise 8.2, question number 1. And we are going to use a theorem that we have done yesterday. Midpoint and converse of midpoint, and in any question, any theorem we can use. Let's start with question number 1. What is given in the question? ABCD is a quadrilateral. Okay, ABCD is a quadrilateral here. So right, given ABCD is a quadrilateral where PQRS are the midpoints of these sides. P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of DA. So these four are given the midpoints. So let us write here P, Q, R, S are midpoint of AB, BC, CD, and DA. This is given, and rest nothing else and important. Nothing else is given in the question. Shubhranshu, you are late by 6 minutes. Now what we have to prove, SR is parallel to AC. Take care. And SR is half of AC. Second is this. Second proving is PQ and SR are equal. And the third is PQRS is parallelogram. All the parts are interconnected. All the parts here are interconnected. Now see how to prove this. So I'm proving this side, right side. Now look here, we have to prove that SR is parallel to AC. SR is parallel to AC. And SR is half of AC. Yeah, this we can prove with the help of, yes, Aditya Chen has already written. How we can prove this? S and R, see this in triangle. See, always you have to look for the triangle. Which triangle they are talking about? See this, SR and AC. We are talking about SR and AC. Then SR and AC are the parts of this triangle ADC. Yes, so in triangle ADC, S and R are midpoints of AD and DC. You have to write in the same way. S and R are the midpoint of AD and DC. Therefore, SR will be parallel to AC and SR will be half of AC. This we have proved yesterday only, that how SR will be parallel to AC and how SR will be half of AC. And this is by midpoint theorem. Now there is no need to prove these questions, just directly you can write by midpoint theorem. I've written this. This is done. Okay. After this, SR is parallel to AC and SR is half of AC. Now we have to prove in second PQ and SR equal. PQ and SR equal. Okay. Now in this triangle, in triangle ABC. See in triangle ABC, if you will be able to understand the first question, then you will be able to understand how to use like theorems. Is the theorem that we have done yesterday, how to use these theorems in these questions. See this now in triangle ABC, P and Q are the midpoint of AB and BC. So PQ will be parallel to AC and PQ will be half of AC, right? P and Q are midpoints of AB and BC. Therefore, PQ is parallel to AC and PQ is half of AC by again midpoint theorem. Now take this as equation 1 and take this as equation 2. From first and second, we can see this SR is also half of AC and PQ is also half of AC. So right side is all same. So left side will also be equal to each other. So SR is also equals to PQ, and this is proved. The second one is proved. PQ and SR are equal. Also, make this as 1. You can leave. Okay, let me write here now. See this, we have already proved that SR is parallel to AC, as we have proved here, and SR is parallel to AC. Sorry, PQ is parallel to AC. Therefore, PQ and SR are parallel also. See one more time. See this, SR and AC are parallel, and PQ and AC are parallel. Here also AC same, it means SR and PQ are parallel to each other. So SR and PQ are parallel to each other, and SR or PQ are equal also. And PQ is equals to SR, therefore PQRS is a parallelogram. If one pair of opposite side is equal and parallel, then it is a parallelogram, hence proved. So PQ and RS are parallel and PQ and RS are equal. Therefore, we can say that PQRS is a parallelogram. Note it down. See, in the starting, we have proved SR and AC parallel, and SR is half of AC. Then we have proved PQ is parallel to AC and PQ is half of AC. And AC was common in both proving. So that's why SR and PQ are equal and SR and PQ are parallel. And if one pair of opposite side is equal and parallel, then it is a parallelogram. The same theorem from exercise 8.1 we have used in between. Sir, please explain once again from equation 1 and 2. Okay. Vivek, just see here. This is clear that we have used midpoint theorem. We have used midpoint theorem first in this triangle. When we have used midpoint theorem in this triangle, then S and R were the midpoints. Therefore, SR is parallel to AC. SR is parallel to AC and SR is half of AC. Afterwards, from second triangle, we have proved that PQ is parallel to AC and PQ is half of AC. Now see these two equations carefully. This and this. Both are saying that SR is also half of AC and PQ is also half of AC. If SR and PQ are half of AC, then SR and PQ will be equal to each other because they both are half of AC. So SR and PQ we have proved equal. And this is done from first and second. After that, also we have proved here that SR is parallel to AC and PQ is parallel to AC. So we'll write here SR is parallel to AC, PQ is parallel to AC. Again, AC is same here. So SR will be parallel to PQ. And also we have already proved that PQ and SR are equal from here. That's why if one pair of opposite side is equal and parallel, then it is a parallelogram. Is it clear now? Okay. Moving on to the next question. Next, ABCD is a rhombus. PQRS are the midpoint of the sides AB, BC, CD, and DA. Show that quadrilateral PQRS is a rectangle. Let us make a rhombus shaped figure. Let me make a simple figure like this. Right. As it is a rhombus, so we are making a rhombus shaped figure here. So it is A, B, C, D. So ABCD is a rhombus where all the sides will be equal to each other. So PQRS are midpoints of AB, BC, CD, DA. So the midpoint of AB is P and midpoint of BC is Q. Midpoint of CD is R, and midpoint of AD is S. After this, join the point. Find these points so that you will be able to make a figure inside. So it is like this from inside. Now we have to show that PQRS, the figure which we have formed inside, is a rectangle. Given ABCD is a rhombus. To prove, and one more thing is given PQRS are the midpoints. So let us write that also. PQRS are midpoints of AB, BC, CD, DA. To prove that PQRS is a rectangle. Proof. And before proving, no, we need a little bit of construction also in this. So let us write construction first. In construction, no, just join DB. I am just making first of all one diagonal, that is DB. Now see this, this inside figure PQRS is a quadrilateral. It is written that PQR is a quadrilateral. We have to prove it a rectangle. So what is the procedure? Quadrilateral first will be proved as parallelogram, then it will be proved as rectangle. I know. So how we can prove PQRS? First a parallelogram. So because of that, I have joined DD. Join DB. Starting with the proving. See in this triangle ADB. First of all, make your aim to prove it a parallelogram. And parallelogram we are going to prove in the same way we have done in the first question. First question. The way first question we have proved no parallelogram. In the same way we have to prove this also a parallelogram. So in triangle ADB, again in this triangle, so in this triangle P and S are the midpoints of AB and AD, right? P and S are midpoints of AB and AD. Therefore, this line joining the midpoints, that is PS, will be parallel to DB. PS is parallel to DB. Moreover, PS will be half of DB. Let it be first by midpoint theorem. You can write in the full form midpoint theorem so that you should not forget it. What we have written, what is this MPT? That is midpoint theorem. After that, similarly in triangle BCD, the white triangle. See this white triangle BCD. And this we have midpoints. Again, Q and R are the midpoints of BC and CD. Q and R are midpoints of BC and CD. Therefore, QR is parallel to DB and QR is half of DB. So let it be second. Again by midpoint theorem. So from first and second, see this PS is also half of DB, QR is also half of DB. So PS is parallel to QR. So PS is equals to QR. And also it is written here, PS is parallel to DB and QR is also parallel to DB. So PS is parallel to QR. If one pair of opposite side is equal in parallel, see this is opposite side. PS and QR are equal also and parallel also. Therefore, PQRS is a parallelogram. So till now, no, we have only proved this quadrilateral as parallelogram. Fine, but how to prove it now as a rectangle? In a parallelogram, I have already told you, in a parallelogram, we have same properties like rectangle, means the opposite sides are equal and parallel. And if you will prove any one angle 90 degree, no, then it will be called as rectangle. In a parallelogram, if you are able to prove any angle out of PQRS as 90 degree, then it will be considered as a rectangle. So how we can prove that? Let us look into the figure now. See now further. Now we have to prove angle PQRS out of any of this as parallelogram. Let us join the other diagonal. Join AC. So AC is also join. Join AC. Since let it intersect at point O. Since diagonal of rhombus bisect at 90. Diagonals of rhombus bisect 90, no? So these all are in middle one, all angles are 90 degree. Okay, so I'm writing here this angle I am considering. See this here. Okay. So diagonal of rhombus bisect at 90. So I am considering this angle, angle 1. So angle 1 is equal to 90 degree. Okay, angle 1 is 90. I want to make this R also 90. If out of PQRS, if I'll make any angle 90, then I'll be able to prove that PQRS is a rectangle. So I am aiming at R now. I am making this R 90. So how I can make that 90 degree? Look now. Let me consider this point as M and this point as N, and this is O. So I am going to prove now R, N, O, M are parallelogram. See this now. S and R are the midpoint of AD and DC. S and R, so see this. S and R are midpoints of AD and DC. Therefore, SR is parallel to AC. SR is parallel to AC. If SR is parallel to AC, then we can say that MR is parallel to ON, because MR and ON are the part of this. Therefore, MR is parallel to ON. Let it be the which equation have we used? Yeah, first and second we have used. So it will be our third equation. Also Rn is parallel to this MO. Rn is parallel to MO. This is already parallel. How it is parallel? Because RQ is parallel to DB. This we have already proved. See this, RQ is parallel to DB. QR is parallel to DB. We have already proved that. So if QR is parallel to DB, then part of this will also be parallel. Look here now, one more time in the figure. We have proved that S and R are the midpoint of this and this. Therefore, SR, this line, is parallel to AC. If SR is parallel to AC, then we can say that this MR will be parallel to this ON, because this is the part. After this, QR we have already proved parallel to DB. Therefore, this RN will be parallel to MO. If opposite sides are parallel, it means RNOM is a parallelogram. So you can write here. So no need to consider this an equation. Just write directly. Therefore, RNOM is a, and in parallelogram, opposite angles are equal. If this one is 90 degree, then this will also be now 90 degree, because opposite angles of a parallelogram are equal. So just write here that angle 1 is equals to angle this R, which is SRQ. So therefore, angle 1 is equal to angle SRQ equals to 90 degree, opposite angles of parallelogram. Therefore, we can say that PQRS is a parallelogram with one angle 90 degree. Therefore, it is a rectangle. Hence proved. Note it down. The question require a little practice. Do practice today and let me know if any confusion is there. Tomorrow you'll get an assignment also in your homework, in your WhatsApp. I have already announced yesterday that there will be an assignment based on chapter number 3, 4, and 6, just to practice some questions. Yes, just run. What? How much times? That is up to you, Jastaran. Aditya, that is not necessary to solve in your notebook. You can practice the questions in practice notebook also. Okay, then this is over. Moving on to the next question. Aditya man, just message me for this. I'll send you. Okay. Now moving on to the next. Question number 3. Question number 3 is also somewhere similar to this question. ABCD is a rectangle now. This is just the reverse of the previous question. ABCD is a rectangle. So making a rectangle ABCD, naming it ABCD, and now PQRS again the midpoint. So PQRS. So PQRS are the midpoints. You have to show that PQRS is a rhombus. You have to prove that PQRS is a rhombus. It seems like rhombus. How to prove that? Given ABCD is a rectangle, to prove, and one more thing regarding the midpoints that we should also write, that PQRS are the midpoints. PQRS are midpoints of AB, BC, CD, and DA. To prove PQRS is a rhombus. Construction. In construction, then just join one diagonal first of all, because there is a requirement of only one in the starting. So we'll draw only one, so that we should not get confused while the solution of the question. Join DB. Right here, join DB. Make the figure and write this given to prove and construction. We'll do half part of the question today, half part tomorrow. Proof. As we know that PQRS is a this quadrilateral. So quadrilateral first to be converted into parallelogram, then a rhombus. You know, as PQRS quadrilateral, we have to convert it to a rhombus. We have to prove that it is a rhombus. So to prove rhombus, first of all, we have to convert it into a parallelogram. And how to convert it into parallelogram? In the same way, the way we have done question number 1 and 2. Again, the first part of the question is same as question number 1 and 2. So starting with this triangle. So in triangle ADB, E and S are midpoints of AB and AD. Therefore, PS is parallel to DB and PS is half of DB. I hope you are clear with this. We have repeated this multiple times till now. So let it be equation number 1 by MPD, point theorem. Similarly, in triangle BCD, also we have midpoints. In BCD, R and Q are the midpoint of CD and BC, or Q and R are midpoints of BC and CD. Therefore, QR is parallel to DB and QR is half of DB. Second, from first and second. Yes, Sahib. What we can prove from first and second? Sahib saying. What we can prove from first and second? See the equation carefully. Any answer? Aditya Jain has written. You have written something wrong, Aditya. Check your answer. Yeah, Vivek Malik has written. Sir, PS and QR are equal. Sahib, you are not attentive. Look here. Akshay has written. See this PS right here. S equals to dB and half of dB. Here QR is equals to dB, parallel to dB and half of dB. Here also PS is parallel to dB and half of dB. Here also QR is parallel to dB and half of dB. So here you're not able to speak, but you can write. No, everybody is writing there. Yeah. Okay. Speak now, Sahib.
PS parallel to dB, PS half of dB.
Yeah, this is fine. And in the same way, we have here also QR is parallel to dB and QR is half of dB. But what will be the conclusion of this?
Yes.
Sahib is not attentive. Many have written here. You should be attentive in the class. Okay. See this here. No, dB is common in both. This dB here also and dB here also. It means PS is parallel to dB and QR is parallel to dB. It means PS and QR will be parallel to each other. In which PS and QR will be parallel to each other and PS and QR will be equal to each other. So therefore, PQRS is a parallelogram. This much only. Now after this, the next part we are going to do tomorrow. The lecture is over. 2 seconds are left. Note it down. Rest we'll do tomorrow. Navan, you were asking for the full solution. Taken screenshot? Okay, bye.